Okay, this is going to be a review for Wednesday over exponentials. So I'm actually going to go through a couple of the problems. This video, I'm not going to go over everything into detail. A lot of you should be able to do this on your own. So I'm only going to guide you and get you started, and then the rest you'll do on your own. So this first video, we're going to do number one. To start us off, for number one, it says that the number of stores opened by a coffee company can be modeled by the exponential function graphed on the grid, where X is the number of years since 1992. So then they give you the graph. Based on the graph, which statement appears to be true? So remember, we're starting at the year 1992. Okay, so that so this would be my at 0 would be 1992, right? That's my starting point. Each year after, so 1 year after 1992, that'd be what, 93, right? 1 year after, 2 years after 1992, that'd be 94, 95, so on, so on. So you got to know to interpret that, right? So let's look at all the questions. So the coffee company for number one, the coffee company had opened 400 stores by the end of 1992. So looking at 1992, is it here at 400? So yes, that checks out, but let's go ahead and read the rest just to make sure, because we don't know. So the coffee company had opened 200 stores in 1 year. So 1 year later, right, 1993, we had 400, 200 more would be 600. So does my graph go up to 600? No, it falls a little bit short, so that one is not true. Every year, the number of stores the coffee company opened increased by 100. So think about it. Each year, it should have gone 100 more. So again, 400 a year later should have been 500. A year later should have been 600, and then 1 year later should have been 700, and boom, that jumped up to 800. So that went more than 100. Since 1992, the coffee company had opened 250 stores each year. And we know that one's not true, because 400 plus 250 would have been 650, and that should have been up here. But no, we only did about halfway, which is only about like 100 more stores. So that one's not true. So A did work out, okay? For number two, this time they gave us a table of some points on the graph. So that's an exponential based on table, which function represents the same relationship. So again, what do we do? And I'm not going to do this one all the way. You're going to do it. You know to put the table in Desmos, right? So you'll go here, you add the table, and you'll put on all your points, 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then you'll put in all your y's. And once you put in the y's, again, I'm not going to do this one with you. Y is 1,000, 1,049, 1,100, 1,157. So you'll put all those in. How do we ask it to give us this equation? Remember, it's y equals a times b to the power of x. So what you're going to do once you have it in, you'll put it in, you put y1, squiggly, approximate, remember, a, parentheses b, parentheses to the power, so you do ab, x1. Remember that? So once you fill in your table, all right, once you fill it in, this will auto-populate. Remember, there's a button that pops up. Let me see if I can get it to pop up. Let me put the first point. Okay, so I put the first point for you guys. Well, I guess it didn't pop up actually. There's a button here that says to turn on like the log mode. Make sure you check it. Okay, so once you put in all your points, this will pop up. So make sure you check it, and then you'll go on ahead and get your answer choice, because without the log mode, your answer will not be correct. So let me see. What's going on? Okay, just give me a second, waiting for this to go away. All right, actually I want to show you, because some of you were barely doing the work today, so I'll just go on ahead and keep populating it. So it's 1,000, 149, 1,100. Ooh, 1,000. 1, 2, 1, 2. Whoop. Okay, so this is the log mode that I'm talking about that's going to pop up. Make sure it's checked, and then that's your A, that's your B. Make sure you're rounding appropriately to find which one's your A and your B, and then circle your answer, okay? So for number 3, the graph of an exponential function is shown on the grid. So based on the graph, which statement of the function is true? So these, if I look at my answer choices, it's the range, the domain, the domain. So they're asking me domain and range. We learned that the domain of an exponential, remember when it runs off your graph this way and it runs off your graph this way, remember domain is your x and you read from left to right, remember? And we learned that of an exponential, on the left side you come in, there's an arrow, right? That means negative infinity. And then you come to the right, there's also an arrow that means positive infinity. So I learned that the domain of all exponentials was all real numbers. Remember that little symbol, which means all real numbers? So for the domain is set of all real numbers greater than 0. No, it's just all real numbers. The domain is set of all real numbers less than -4. No, it should just be all real numbers. So those cannot be true. It should just say all real numbers. So now for range, I don't know if you remember, range is my y's, and we read from bottom to top, right? So that's bottom, this is top. Well, we know this is an exponential, and what do we notice that's sitting at the bottom of my exponential, right? Why does it curve and then have a flat line? So do y'all remember what's sitting at the bottom? Remember, it is this thing called an asymptote. All right, so where is my asymptote sitting? Here on the y-axis. So here's my y. All right, my asymptote right under it, here it is, that's why it's stopping, is right here at -1, 2, 3, 4, is at -4. So I know by looking at my graph, the range, the y's, are they going to be greater than -4 or are they less than -4? Okay, so the answer choice would be B, because A is the range set of all real numbers less than 0. So that means we'd come here at 0 and the graph would only be below 0, which is not true because there's some points above 0. So that cannot be true. Okay, so your answer would be, remember, you always go from the asymptote, the bottom, the asymptote sits at the bottom, and then you look at the graph. Is it above the graph or below the graph? I mean, below the asymptote. Okay, number 4. So this one, they gave you the exponential function model below, represents the number of square kilometers of land occupied by cane toads X years after this animal was first introduced to Australia. So they give us the graph and they give us the table, right? And so again, we need the equation. But guys, let's just try to eliminate some of our answers based on the data. Which exponential equation can be used to model this information? First of all, is this a growth or a decay? All right, so I'm coming up, right? I'm a growth. Remember, y equals a parentheses b to the power of x. Remember, if it is a growth, right, are we, the number, the b, right, this one, are we adding to 1 or are we subtracting from 1? Y'all remember? We should be adding, right? So if you look at your answer choices, B, they took the number 1 and they subtracted it. Well, this is a growth. Are we supposed to subtract? No. Remember, if you're adding, so if we're growth, the number is bigger than 1. If we're subtracting and we're decay, we are less than 1. So look here. Okay, they're adding. That checks off. This number, is it bigger than 1 or less than 1? It's less than 1. So this one doesn't work because I'm a growth again, and anything less than 1 tells me I'm a decay. This one, is this number bigger than 1? Yeah, it's really big. that doesn't look right. It's a little too big. But just to make sure, I'm still going to go in, put your points in. So once you have this equation in, leave it there. Just erase your table. Okay, so you'll put in your points, 0, 5, 10, 15, 20. So it goes all the way to 35. 0, 5. Okay, and then, so the other numbers, now it's talking about area, which is really big. So you'll put all of them in, right? 36,500. Okay, so you'll kind of keep going. And then this is not correct, right? Because I'm not done. You have to put in every single point. And then so once you're done, you'll look at your A and your B, and you'll match which one's looking at it, okay? If you guys haven't already figured it out. The last one I'm doing in this video is number 5. So the population of a town is decreasing at a rate of 3.5% per year. The population of the town was originally 28,000 in the year 2000. Originally, right? Which function models the population in the town after X years? So remember, we know that my starting point, A is my starting point. So how much am I starting with? A. So which two can I eliminate? And then the B tells us if we're growing, right? So if you're growth, what do? You do 1 plus the rate. And then if you are decay, I'll do it down here. Right, you do 1 minus the rate. So remember, and this rate needs to be turned into a decimal. That's 3.5%. So how many cents is that? You move it over. Right, so that would be 0.035. So if we're decreasing, what are we doing? Are we adding or subtracting? We should be just subtracting. So what number is that going to give us for the B? Okay, so I'll let you figure that out. That's the B. So that's the number that goes in parentheses, okay? And that's it for this video.